Hi everyone, in this video I will discuss eigenvalues and eigenvectors. But before I start, I would like to introduce myself first. My name is Arnel Silva Jr., a third-year college student from Calabanga Community College taking Bachelor of Secondary Education major in Mathematics. Eigenvalues and eigenvectors. Eigenvalues are associated with eigenvectors in linear algebra. Both terms are used in the analysis of linear transformations. Eigenvalues are the special set of scalar values that is associated with the set of linear equations, most probably in the matrix equations. The eigenvectors are also termed as characteristic roots. It is a non-zero vector that can be changed at the most by its scalar factor after the application of linear transformations. And the corresponding factor which scales the eigenvector is called an eigenvalue. So let's define what is eigenvalues. Eigenvalues are the special set of scalars associated with a system of linear equations. It is mostly used in matrix equations. Eigen is a German word that means proper or characteristic. Therefore, the term eigenvalue can be termed as characteristic value, characteristic root, proper values, or latent roots as well. In simple words, the eigenvalue is a scalar that is used to transform the eigenvector. So the basic equation is ax equals lambda x. So lambda, yung parang baliktad na y, it is called lambda and it represents eigenvalue and scalar. So the number or scalar value is an eigenvalue of A. So let's define also the eigenvector. Eigenvectors are the vectors or non-zero that do not change the direction when any linear transformation is applied. It changes by only a scalar factor. In a brief, we can say if A is a linear transformation from a vector space, V and X is a vector in V, which is not a zero vector, then V is an eigenvector of A if A of X is a scalar multiple of X. So the eigenvalues of a square matrix. Suppose A sub n times n is a square matrix, then A minus lambda I is called an eigen or characteristic matrix, which is an indefinite or undefined scalar, where the determinant of eigenmatrix can be written as A minus lambda I and A minus lambda I equals 0 is the eigenequation or characteristics equation, where I is the identified matrix. The roots of an eigenmatrix are called eigenroots. Eigenvalues of a triangular matrix and diagonal matrix are equivalent to the element on the principal diagonals, but eigenvalues of the scalar matrix are the scalar only. So let's proceed to properties of eigenvalues. Eigenvectors with distinct eigenvalues are linearly independent. Singular matrices have zero eigenvalues. If A is a square matrix, then lambda is equals to 0 is an eigenvalue of A. For a scalar multiple of a matrix, if A is a square matrix and lambda is an eigenvalue of A, then A lambda is an eigenvalue of A. For matrix powers, if A is a square matrix and lambda is an eigenvalue of A and n is greater than or equal to 0 is an integer, then lambda n is an eigenvalue of an. For polynomials of matrix, if A is a square matrix, lambda is an eigenvalue of A and p of x is a polynomial in variable x, then p lambda is the eigenvalue of matrix p of A. Inverse matrix, if A is a square matrix, lambda is an eigenvalue of A, then lambda minus 1 is an eigenvalue of A minus 1. Transpose matrix, if A is a square matrix, lambda is an eigenvalue of A, then lambda is an eigenvalue of AT. So let's have an example of eigenvalue. In this shear mapping, the blue arrow changes direction, whereas the pink arrow does not. So here, the pink arrow is an eigenvector because it does not change direction. Also, the length of this arrow is not changed. Its eigenvalue is 1. So, the eigenvector here is the pink arrow because hindi siya nagbago ng direction. And also, the eigenvalue is the length of the arrow, wherein it doesn't change. So let's have an example of eigenvalues of 2 by 2 matrix. So we have matrix A with an element of 1, 1, 4, 1. To solve it, we have our given, which is matrix A with an element of 1, 1, 4, 1, and the I, which is represent the identify matrix, which is 1, 0, 0, 1. So our solution is, so we use the A minus lambda I, and we need to substitute the value. So it is equals to 1, 1, 4, 1 minus the lambda, 0, 0 lambda. So it is equal to 1 minus lambda, 1, 4, 1 minus lambda. So to find the eigenvalues, we need to write it 1 minus lambda, 1, 4, 1 minus lambda equals 0. And then we need to find the determinants of this matrix. So we have 1 minus lambda times 1 minus lambda minus 4 times 1. So we have 1 minus 2 lambda plus lambda squared minus 4 equals to 0. And then we will write it lambda squared minus 2 lambda minus 3 equals 0. And to find the value of lambda, we need to factor it. So we have lambda minus 3 times lambda plus 0 equals 0. So that our lambda is positive 3 and negative 1. So we have one pair of eigenvalue. So next, we need to find the eigenvectors of 2 by 2 matrix. So our given is matrix A with an element of 1, 1, 4, 1, and then we will use the lambda or the eigenvalue 3. So we need to substitute the value of A minus lambda I times x equals 0 vector. So we have A minus 3I, or the identify matrix, equals 1, 1, 4, 1 minus 3, 0, 0, 3. So we have negative 2, 1, 4, and negative 2. And then to get the eigenvectors, we need to use the row operations. So after we use the row operations, our final answer will be negative 2, 1, 0, 0. And then next is negative 2, 1, 0, 0 times the x sub 1 and x sub 2 is equals to 0, 0. And then it will be negative 2x sub 1 plus x sub 2 equals to 0. So the x sub 2, we will choose a number which is 1 to substitute and to get the vector. So our eigenvector will be 1 and 2. So let's have an example of eigenvalues of 3 by 3 matrix. So we have matrix A with an element of 1, 0, 0, 3, negative 2, 0, 2, 3, 4. So our given is matrix A with an element of 1, 0, 0, 3, negative 2, 0, 2, 3, 4. And then the identify matrix, you have 1, 0, 0, 0, 1, 0, 0, 0, 1. So our solution is we need to substitute the value of A minus lambda I. So we need to multiply first the value of identify matrix to a lambda, and after that we need to write it by A minus lambda I. So we have 1 minus lambda 0, 0, 3, negative 2 minus lambda 0, 2, 3, 4 minus lambda, and after that we need to find the determinants of it. So we have 1 minus lambda times negative 2 minus lambda and 4 minus lambda minus 0 times 3 minus 0 plus 0. So we have 1 minus lambda times negative 2 minus lambda and 4 minus lambda equals to 0. So we need to find the eigenvalue by transpose of it. So we have our eigenvalue, we have 1, negative 2, and 4. So after that, we need to find the eigenvectors of 3 by 3 matrix. So our given is matrix A with an element of 1, 0, 0, 3, negative 2, 0, 2, 3, 4. And then we will use one of the value of the eigenvalue, which is lambda is equals to 1. So we will use, or we will substitute the value of lambda. So we have A minus 1 times lambda is equals to 1, 0, 0, 3, negative 2, 0, 2, 3, 4 minus 1, 0, 0, 0, 1, 0, 0, 0, 1. So we have 0, 0, 3, negative 3, 0, 2, 3, 3. So to find the eigenvectors, so we will write it by 3 x sub 1 minus 3 x sub 2 equals to 0. So we have x sub 1 is equals to x sub 2 and it is equals to 1. So the next eigenvectors is 2 plus 3 plus 3 x sub 3 is equals to 0. So we need to add both terms and transpose it, and after that we need to divide it by 3. So we have x sub 3 is equals to negative 3 over 3. So our eigenvectors is 1, 1, negative 5 over 3 by using the eigenvalue of 1. So that's all. Thank you.